Now we'll discuss linearly independent vectors. So if we have a set of vectors, we say they are linearly independent if the equation x1a1 plus x2a2 all the way up to xn an equal to 0 has only the trivial solution. Otherwise, we say they're linearly dependent. So for example, here's a set of vectors, and if I want to figure out if they are independent or dependent, I put them in a matrix and see what happens. So we have our vectors on the left, and in my definition of linear independence, the right-hand side would be 0. So typically when the right-hand column, the augmented column, is all zeros, we don't write it. So we'll just leave it out. Mainly because no matter which row operations you do, it's going to remain all zeros. So once we reduce this, we get 1, 0, 0, 0, 1, 0, 1, 6, 1. So here we can see that there's a pivot in every column. This means that there are no free variables, which means these would be independent because there's only one solution, 0, 0, 0. A lot of times we can look at things to see if they have a trivial solution or a non-trivial solution to determine if they're independent or dependent. So I'll look at each one of these individually. Let's start with a single vector. So if a single vector is dependent, we need this equation x1a equal to 0 to have more than one solution. Well, here, one of these things has to be 0. And if it's not x1, then it has to be a. So if a is equal to 0, it's dependent. Otherwise, it's independent. And it's actually the case that any set of vectors that contains the 0 vector will be linearly dependent. Now let's consider two vectors. So two vectors are dependent if and only if x1a1 plus x2a2 equal to 0 has a non-trivial solution. This being non-trivial means either x1 can't be 0, x2 can't be 0, or neither one of them are 0. We'll suppose that's x1 that is definitely not a 0. Well, in that case, I can solve for a1. I get a1 is equal to minus x2 over x1 times a2. So two vectors are linearly dependent if and only if one of them is a scalar multiple of the other. So I should be able to multiply the first one by a scalar to get the second one for them to be dependent. The final case that can be done by observation, free variables are unavoidable. So if we have more vectors than entries, then the set of vectors is linearly dependent. So more vectors than entries mean I have more rows or more columns than rows. So even if I have a pivot in every single row and no row of zeros, I still have this other column that's going to force a free variable. So anytime I have more vectors than entries in each vector, they will be dependent because it will be physically impossible to not have a free variable. Now let's determine if each one of these are independent or dependent. So here's a set of two vectors. And if we notice, if I call the first one A and the second one B, that I can actually do 5 over 2A is equal to B. So these are linear combinations of one another. So these are dependent. These three, we'll see that this right here is the 0 vector, and anything that contains the 0 vector will be dependent. My final example here, you see I have 4 vectors, each one with 3 entries. And so this is also going to be dependent.